Welcome to another video on polynomial functions. For this example, we are given the function f of x. We are asked to find these parts. On letter A, find the zeros of the function. Recall that the zeros of a function are the x values for which the function value is 0. And hence, our first step is to set f of x to 0. Now we have a statement that we can solve for x. Hence, the function value is now 0, and it's equal to -4 times the quantity x plus 2 raised to the power of 3 times the quantity x plus 1 times another quantity x minus 3 squared. In order to solve this equation for x, notice that the non-zero side is already in factored form. And therefore, using the zero property of equality, we can set each factor that has an x in it to 0 and solve. Hence, x plus 2 quantity cubed is 0, x plus 1 is 0, and lastly, x minus 3 quantity squared is equal to 0. Notice that the coefficient -4 does not contribute to solving for the value of x, since there is no x with the coefficient -4. If we were to set that number to 0, this gives us a false statement, and therefore no solution can be obtained from solving that statement. And now from the first factor that is set to 0, we're going to cube root both sides, which turns this into x plus 2 is equal to 0. And then solving for x, we get a value of -2. Now notice that this has a multiplicity of 3 since that factor occurs 3 times in the polynomial function. But for letter A, we're simply looking for the zeros. Moving on to the next factor, setting the second factor to 0 and solve, we get a value of -1. And then lastly, setting the third factor to 0, we're going to square root both sides. Since taking the positive and negative square root of 0, we obtained the value 0, and therefore x minus 3 is 0, giving us a value of +3. So that's for part A. For part B, find the number multiplicity for each 0. So we're just going to take part A, x equals -2. As mentioned before, this one has a multiplicity of 3. Since the power on that factor is the value 3. X equals -1. This one has a multiplicity of just 1, since this is only raised to the first power. And lastly, x equals 3. That 0 has a multiplicity of 2. Again, there are 2 factors of x minus 3. For letter C, determine the x-intercepts and the y-intercept of the graph of the function. Now remember that an x-intercept is a point on the graph of a function that crosses the x-axis. So essentially, that's the same process as solving for the zeros of the function. The only difference is we write x-intercepts as order pairs. And so using part A, the x-intercepts of the graph of the function are -2, 0, -1, 0, and 3 followed by 0. So we're just simply taking the values from letter A, which are called the zeros of the function, and then using them as the x-coordinates of the points that intersect the x-axis, hence calling them x-intercepts. As you can see, they are written as order pairs. And now for the y-intercept, recall that a y-intercept is a point on the graph of a function that intersects the y-axis, and therefore, to algebraically solve for the y-intercept, we set x equal to 0. Using the function defined here, if we let x equal 0, notice that the y value then becomes -4 times the quantity 2 to the third times 1 times -3 squared. So let's take this work and bring it down to the bottom so that we can algebraically solve for y there. And so simplifying this statement, we have -4 times 8 times 1 times 9. And so simplifying this, we get -32 times 9, which is -288. So the y-intercept is 0 followed by -288, writing it as an ordered pair as well. On letter D, determine the end behavior of the function f of x. So to determine the end behavior, we need the leading term test. And so the leading term comes from multiplying -4 to x raised to the power of 3, since we have 3 factors of x plus 2. So on this particular factor here, quantity x plus 2 raised to the third power, if we expand that out, we're going to end up with a cubic term, specifically x to the third. And then we're going to multiply that to the leading term of the next factor, and then the leading term of the third factor. Now, the third factor is quantity x minus 3 squared, so the leading term there is going to be an x squared. Hence, we basically end up having a function whose leading term is going to be -4 times an x to the third times an x squared, which turns this into -4x raised to the power of 6. Remember, when we multiply expressions of the same base, we add their exponents. That is the product rule of exponents. And so this is called the leading term. And hence the leading term has a degree of 6, which is now the degree of the polynomial function. It means that the ends point in the same direction. But since the leading coefficient is negative, both ends point down. So we're just going to use this drawing here to indicate that for letter D. Both ends point down. On letter D, determine the maximum number of turning points the graph can have, and that is based on the degree minus 1. So we've seen on letter D, the degree of the function is 6, and therefore n minus 1 is 6 minus 1. Hence, this is now the maximum number of turning points on its graph, which is the value 5.